You don't know what I mean by the forbidden rule? Yeah, it's when, remember, the freak and the forbidden rule is when people think they can just square that, which we know we cannot, which I didn't see anybody do that, so that's awesome. So what, I'm not going to go through it. You know how to do it. What was the answer? Check your answer. If you got it right, awesome. Okay, erase your whiteboards. Let's go again. I need you to go quicker this time. X minus 1 cubed. Double time it, go. Don't talk, double time it, go. Above all, do not get it wrong. Just kidding. Guys, let's go ahead and multiply that out. Quick, quick, quick. Go, go, go. Well, is there any other way? No. Not that you've learned. You guys, is this going to take you a dang long time? Yeah, the rest of the class period, I'm trying to make a point here. You would not want to do this, right? You would not want to do this. I'm telling you, this would take you like the whole class period, and then probably you'd get it wrong, which would be bad, you know? So the cool thing is, that's what we're doing today, is we're doing a random kind of lesson that has nothing to do with what we've learned so far, but I'm going to teach you a quicker way to multiply this out instead of having to go through it the long way. So it's really cool. See, that's how you'd feel if I really had you keep going with that, is you'd be pretty upset. Because then you'd get it wrong. And then, once you got it wrong, that face would turn to this face. Okay. Thanks for laughing at my joke. Who did that? You get bonus. Hey, your fake laugh is not appreciated, mister. Okay. Do you want me to actually make you cry? Because I promise I can. Okay. Okay. All right, here we go. So the cool thing is let's just get right into it. It's really cool. So Pascal is a mathematician. He started multiplying out these binomials. Now remember, binomials means two terms. So look, this was a binomial. Binomial. You get the picture. So what this mathematician did is he started multiplying out these binomials by hand. And he kept doing all these different ones. And he noticed that every time this pattern was happening. Now, you can use Pascal's triangle to expand a binomial of any degree. What this allows you to find is the coefficients. Which, remember what coefficients means. Coefficient is the number in front of the variable. So I want to show you. So notice right here we have a 1, a 1, a 1, a 1, a 2, a 1, a 1, 3, 3, 1. So I want you to look right here. If I was to multiply out x minus 1 to the 0 power, it does become 1. Do you see how I get a 1? Now, if I multiply out x minus 1 to the first, my coefficients would be 1, and ignore the negative, 1 and 1. Well, do you see how I have a 1 and a 1? If I was to multiply out x minus 1 squared, my coefficient would be a 1, then a 2, then a 1. 1, 2, 1. If I multiply out x minus 1 cubed, I get a 1, a 3, a 3, a 1. Look. 1, 3, 3, 1. So this mathematician noticed that this pattern always happens in a sense. So first of all, I'll show you how to create this Pascal's triangle, and then I'll show you how to use it. So we have to be able to, by hand, you don't want to memorize this. This triangle literally goes on forever. Because we can put any degree. I'm going to show you how to create it. So first of all, this top row, this 1 right here, is degree 0. Then degree 1, degree 2, degree 3, degree 4. So I want you to notice the first thing here. Do you see how down the diagonals is always 1? That is always going to be true. And then the pattern works out. So let's grab a blank piece of paper. So it's a triangle. So we start with our diagonals are always 1. So we start at the top of our triangle with a 1. Kind of write really small, guys. You guys write smaller than I'm writing. In the middle of your paper for sure, because we're going to expand outward. Okay, now this has 1 term. The next one should have 2 terms. So the diagonals are always 1. So 1 and 1. Is everybody good? So now we go on to our third row here, and our diagonals start at 1. So put 1s out here. And if there was 2 terms, there needs to be 3 terms down here. So there's going to be a term in between here to make our third term. So what you do is you literally just add the 2 above it. What's 1 plus 1? 2. Okay, let's move on to the next one. So you would put 1s on your diagonals, keeping it really organized. And now there was 3 here, so there needs to be 4 here. So we need 1 in between here and here. So you add 1 plus 2, which is 3. 2 plus 1 is 3. Now look, a pattern happens. It goes up and then back down in the same pattern. 1, 3, 3, 1. That will always happen. So you put 1s on your diagonals again. Then 1 plus 3 is 4. 3 plus 3 is 6. So do you see how it goes in between? And then you can count. There was 4 here. There needs to be 5 here. 3 plus 1 is 4. Look. 1, 4, 6, 4, 1. Okay, let's keep going. We're not even close to being far enough yet. So put 1s and 1s. 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. Now you're going to want to keep that. You're going to want that for the whole time. So make sure you have that written down or take a picture of it. It's sad that you did all that and you don't get to keep it. You have to erase it. I don't know why I changed colors just for kicks and giggles. So 1 and 1. Now we'll keep going. 1 plus 5 is 6. 5 plus 10 is, keep it organized. 10 plus 10 is 20. And then it goes in that same pattern. 15, 6, 1. Okay, now once again, I told you, this is where a lot of people forget. This is degree 0. This is degree 1. I made myself a little note, so it's quick. Degree 2, degree 3, degree 4. These are the coefficients we're going to see. Degree 5, we've only gone up to degree 6. I need you to keep going for a long time, a way long time. So you guys continue to create this triangle. It goes on forever. I want you to at least get up to 12. Ready, go. It's going to start to get huge. You're going to need a calculator. Keep it organized. I want to point something out again. This will be important to realize. Something to the degree 0 will have 1 term. Something degree 1 will have 2 terms. 1, 2. Something degree 2 will have 1, 2, 3 terms. So there's always one more term than degree. So look, degree 6, you know, should have 1, 2, 3, 4, 5, 6, 7 terms. So if I said to you on the test, with your knowledge of Pascal's triangle, how many terms would a binomial x minus 2 to the 20th, how many terms would that have? 21, right, everybody? Okay, so there's one more term than there is degrees. Awesome. So for now, I've only got up to degree 6. Do most of you have a little bit further? Okay, cool. Let's start seeing how to use it. So everybody went to number 1 on your worksheet, but you are not going to be able to fit any work on your worksheet. You will do this all on a blank sheet of paper, and you will not even have to transfer your answer over. You'll just staple the paper to your blank worksheet and hand it in with your name on it. Okay? Grab a blank sheet of paper right now. You need to be doing number 1 with me. So what Pascal's triangle does is it gives us the start to multiplying this out a little bit quicker than doing it by hand. So the first thing you do is you say, this is degree 4. I need to locate the coefficients of degree 4. Remembering degree 0 is where we start. Degree 0, 1, 2, 3. Everybody, do you see how this is degree 4? So our coefficients you're going to write out like this, giving yourself plenty of room. So we start with a 1, spread it out, 4, then 6, then a 4, then a 1. These are the numbers in front of the variables to start with. Now what you're going to do, so you're giving yourself plenty of room. We're expanding this. We're actually multiplying this out, but with a trick. We're going to take this, which is considered our front thing. What you're going to do with the front thing is you're going to take it, x, and you're going to start at the highest degree of 4 and count down to 0. So we're going to start here with an x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, x to the 0. So you should start at the highest degree, clear down to 0. Then what you're going to do is take your back thing. You include the sign. The back thing including the sign. So it's positive 2. And you do the opposite. You start at 0 and count up to the highest degree, which is 4. So you're going to want to use parentheses. Just get in the habit of using parentheses. Positive 2 to the 0. Counting up. Positive 2 to the first. Positive 2 squared. Positive 2 to the third. And then positive 2 to the fourth. Now the nice thing is there's a couple ways to check have I probably done this right. And you should always kind of check before you start simplifying anymore. So because it's degree 4, everybody, before you simplify, you're going to see that it's always degree 4. So what's 4 plus 0? 4. 3 plus 1 is 4. 2 plus 2 is 4. 3 plus 1 is 4. 0 plus 4 is 4. So that's a way to say, have I set this up right? Yeah, it looks good so far. Yep. Number is the coefficient, which is the number in front of the variable. Okay, so now we just simplify each piece. So think about it. Isn't 2 to the 0 a 1? 2 to the 0 is 1. 1 times 1 is 1. 1 times x to the fourth. X to the fourth. We've just simplified our first term. So now right here we have a 2 to the first, which is 2. 2 times 4 is 8. And then we have an x cubed. And it was positive. There was no negatives here. So plus 8x cubed. Now right here, careful, we have 2 to the second power, which is 4. 4 times 6 is 24. We have positive 24, and then we have an x squared. And then we have 2 to the third, which is 8. 8 times 4 is 32. So positive 32x. And then we have an x to the 0, which we know is 1, not x to the 1. It's gone. It becomes a 1. So we have a 1 times 1 times 2 to the fourth, which is 16, times 1, which is 16. So plus 16. And look at that. It's expanded and it's in standard form. We've multiplied this out, but much quicker. Isn't that kind of cool? Once you get quick at this, I promise you, I would have beat you doing it this way than doing it the long way. Especially if we start getting up to degree 10 and stuff like that. You would be way, way quicker doing it like this. Yeah, cool, right? No. You don't need to trash your answer. We're all just about practice. I don't care how you just leave it on blank paper. Let's do a bigger one. Number 2. Here we go. Go to number 2. So a plus 2 to the 7th degree. So degree 0, 1, 2, 3, 4, 5, 6, 7. So there's my coefficients. You got to give yourself some room. So I got to write kind of small. So a 1, 7, 21. Got to write pretty small here. 35, 35, 21, 7, and then 1. I'm going to change colors because it's going to get kind of messy here. So we take our front thing and you start at the highest degree counting down. So a to the 7, a to the 6, and so on. You should end at a to the 0. Now I'm going to take my back thing, including the sign. It's positive again. I'm going to use parentheses, and you start the opposite. So 2 to the 0. And a really good way to make sure you are hopefully on the right track is to say, okay, it's degree 7. Degree 7, degree 7, degree 7. They have to be 7, 7, 7, 7, 7. I haven't messed up anywhere. Okay, now we'll start simplifying it very, very carefully here. So now we would say, okay, we have a 2 to the 0, which is 1. 1 times 1 times a to the 7th. A to the 7th. Now we're going to need a calculator in a minute. Not right now, though. 2 to the first is 2. 2 times 7 is 14. So plus 14, a to the 6th. Now we have 2 to the second power, which is 4 times 21. Thank you. So plus 84, 8 to the 5th. Then we have a 2 to the third, which is 8. 8 times 35. Plus 280, 8 to the 4th. Thank you so much. Then we have a 2 to the 4th times 35. You should all be typing it in. 2 to the 4th times 35. $560. Thank you. 8 to the 3rd. 2 to the 5th times 21. We're almost there. 2 to the 6th times 7. $448 to the first, so I'm just going to write A. Then don't forget A to the 0 is 1, gone. 1 times 1 is 1, 2 to the 7th. 128, perfect. And look at that, we multiplied it out from, and it's in highest degree to lowest degree. It is cool, right? Okay, so try one by yourself now. That is way quicker than doing it by hand. So do number 3, and then we'll get to some with more Not any harder, same exact process. We don't have to learn anything else today, but it's just some of them have more So this is the answer to number 3. Did you all get it right? Okay, let's do one with a negative, but first let's talk about what to expect. So let's do number 9. Now we have some negatives. So starting out with something to show you, you gotta be really careful with negatives. People start messing up major. So we're gonna start out with n minus 3 to the 3rd power. So we would go degree 0, 1, 2, and 3. So our coefficients are 1, 3, 3, 1. Then our front thing is n. So we would do n to the 3rd, n to the 2nd, n to the 1st, n to the 0. And you'll take your back thing, including the negative. So you got to use parentheses. This is so important. So you're going to do negative 3 to the 0, negative 3 to the 1st, negative 3 squared, and negative 3 to the 3rd. So we got to be really careful because here we go. So let's now simplify it. Negative 3 to the 0, isn't that a 1? 1 times 1 is 1, 1n cubed. Next one, a negative to an odd power is negative. So negative 3 to the 1st is negative 3. Negative 3 times 3 is negative 9n squared. Nope, a negative 3 to the 0 is 1. You're not using parentheses around your thing. Okay, negative 3 squared. This is a good point to make. If you so choose to type that into your calculator, you must use parentheses. But negative 3 squared is positive 9. 9 times 3. Positive 27n to the 1st. Now we have n to the 0, which is 1. 1 times 1 is 1. Negative 3 to the 3rd power. It is negative because it's odd. And if you type it into your calculator, use parentheses. Negative 3 to the 3rd is negative 27. What I want you to notice is our answer is bouncing between positive, negative, positive, negative. If there's a negative, it will always bounce. So that's a way to check. Why would it bounce? Because odd degree, even degrees. Odd degree, even degrees will make it bounce between positives and negatives, right? Okay, cool. Okay, another one that's like the most advanced that we'll see probably for the most part, and then I'm going to let you just practice a few. Oh, good question. Do we combine like terms? Yes, but there are no like terms. Adding an n cubed to an n squared would be adding an apple to an orange, right? So this is as far as it can go. Good question. It will be in standard form for you, always. We don't have to go through it. No, yeah, good question. So the nice thing about this is, yeah, it already puts it in standard form. Okay, this is the last one I'm going to do. And I'm going to let you go for it. So it's 3n minus 2n to the 5th. These are the ones of the level you're going to see on the test. These are the ones that people royally screw up on. Because we have a 3 and an n. Yeah, we have a lot going on here. So it's degree 5. So degree 0, 1, 2, 3, 4, 5. I'm gonna have to really write this differently to get it all in there. So you'll see how I'm gonna just write it a little differently. 1, 5, 10, 10, 5, 1. I'm gonna write below it because I can't squeeze it in here and read my own handwriting. So I'm gonna take my front thing. Now here's what's important. The front is both 3 and m. You gotta use parentheses. So right here we have both 3 and m all to the 5th. 3m to the 4th. Both 3m to the 3rd. You get the picture. Use parentheses. Because it's both 3 and m is the front thing. So you have to do the front thing all to the 5th. Why am I writing it below? Because it's too squishy to write it in there. We'll just have to remember that they're next to each other. What? It's just because it's too squishy for me to fit it in there. Okay, then I have a negative and a 2n, and that's my back thing, so I've got to use parentheses, negative 2 and n to the 0. I got to write it below. It's too squishy. They are being multiplied, though. Negative 2n to the 1st. And I am going to check that one little special thing I can check. Before you simplify, since it's degree 5, they should all be degree 5. Look, degree 5, 5, 5, 5. If you add them up, 5, 5. Okay, cool. Now I'm going to simplify. Watch very carefully how easy it is to mess up. We have a 1, and don't we also have 3 to the 5th? 3 is raised to the 5th. It's not breaking the forbidden rule because that's a multiplication sign. You do need to do 5 to that and that. So we have a 1 times 3 to the 5th times negative 2 to the 0. Isn't anything to the 0 gone? Okay, I'm going to cross that out. So we have 1 times 3 to the 5th. What's 3 to the 5th? So this became 243 and then m to the 5th. Next one, careful. Look, you have a 5 times 3 to the 4th times negative 2 to the 1st. Use parentheses, type that in. I'm going to get my coefficients. 5 times 3 to the 4th, and then you have a negative 2 to the 1st. No. No. Negative what? Negative 8, 10, and then we have an m to the 4th, don't we? And n to the 1st. Times 5 times negative 2. Yeah. Do you guys see how I'm just putting the numbers in front? That's what we're multiplying all this together. So we're just multiplying all the numbers together. Okay, so let's do the next one. Everybody look up here. We're going to do a 10 times 3 to the 3rd times negative 2 squared. So plus 1080, and then look, we have m cubed, and we have an n squared. 10 times 3 to the 2nd times negative 2 to the 3rd. It should be bouncing between positive, negative, positive, negative. Negative 720, we have an m squared. We have an n cubed. 5 times 3 times negative 2 to the 4th. Good thing we have Dave in here to do all the math for everybody. So plus 240, and then we have an m and an n to the 4th. And then right here, at 3 and m to the 0, isn't that gone? Be a 1. So we have a 1 times negative 2 to the 5th. Negative 32 n to the 5th. And look, it's already in standard form for us. So do you see why people mess up? They don't look really carefully. They don't do the 3 to there to there, the 2 to there to there. Awesome. Are you doing by yourself now? Okay, cool. So what I'm going to have you do is pick on the section 1 through 20, you're not doing them all. You're going to pick 3 harder, don't pick all the easy ones. I'm not going to put the easy ones on the test. Pick 3 harder problems and do them and check them. Ready, go. Yeah, but we're going to move on to the next section, but I'm only requiring you to do 3. Ready, go. So 21 says, find only the third term in the expansion of this. It doesn't want the whole thing out. It only wants the third one in. So that's kind of nice because you just only go in 3 and only find the third one. So with it being 12, can anyone tell me what the coefficients were for 12? Because I don't have it far down enough. Now, why am I going to stop there? Because didn't I, okay, perfect, good. So do you see how we only need the third one in? So what I'm going to do is I'm going to go, okay, I only need this one. So I'm not even going to write it all out. 66 is what we need, right? And then we take our front thing, and what do we do? X to the 12, X to the 11. So this will be X to the 10. Then we take our back thing, 3 to the 0, 3 to the 1. So this will be 3 to the 2. We only want the third one in. So now we calculate it. 3 squared times 66. This? Yep. 594. And then don't we have x to the 10? This says x plus 3 to the 12th. Find the third term. This is our first term, second term, third term. Yeah, isn't that the third term? So why do all the whole thing when you can just find the third term? So our answer would be 594 x to the 10. Okay, cool. One more like that. Look at 22 with me. It says find the second term in x plus 3 to the 9th. So everybody look. We want the second term in. Look, here's our first term, here's our second term. Isn't it a 9? Wait. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. Everybody, do you guys see what I'm doing? Degree 9. I only need the second one, the second term. So I'm going to have a 9. Is everybody with me? Then our front thing, since it's our second, will be x to the 9th, x to the 8th. Then our back thing is a 3, so we'll have 3 to the 0, 3 to the first. So now we would say 9 times 3 is 27, x to the 8th. And we found the second term in expansion. That's more likely what they would ask you on an ACT, because otherwise it would get too long. This would test your knowledge of Pascal's triangle. I would know you understood it completely just by asking the third term of expansion, second term of expansion. So just so you know. Okay, cool. So what I want you to do is in that section, also pick 3. So you pick 3 hard ones in 1 through 20. You pick 3. And also now you're going to pick 3 in 21 through 28 that we did not just do. Pick 3 more. Make sure you're good. And then once you've done that, you're good. You'll check it off with me.